So we have a situation where our topology has 4 switches, and for some reasons they all have the same information. So basically, if we look closely, we can see that this guy, technically, from the perspective of switch B, in order for us to get to switch A, we have 2 options: to go through A directly or to use D. If we go into B to A, then that's a 19. If we go into B to D to C to A, that's a cost of 19 plus 19 plus 19, that's around 57. And so by default, this guy will become a root port. Same applies to this device. This guy will become a root port. The same mechanism. Now, when we get to the perspective of switch D, we have 2 directions. So we can either go through D to B to A, or we go through D to C to A. And if we do D to B to A, we have 38 here, and because 19 plus 19. And if we go from D to C to A, we also have 38 there. So technically, there's a tie. And if there's a tie based on the cost, the next thing we want to ask is, who are we connected to on the 2 sides? So from the first link, we connected to switch B. And on the second link, we connected to switch C. And what do we mean? So we connected to switch B. If you go through the left, we connected to switch. So we connected to switch B. If you're going through the left, connected to switch C. If you're going through the right. But what do we mean by switch B and switch C? We're looking at what we call the bridge ID. So the bridge ID for the 2 devices is what we're actually looking for. What's the bridge ID for switch B and what's the bridge ID for switch C? Clearly, the bridge ID for switch B is lower, so this is 0, and this is starting with the 1 because the 32768 is the default and they all have the same one. So we'll be looking at the MAC address, and based on the MAC addresses of the 2 devices, we can clearly see that switch B has a lower MAC address. And so the port connected to switch B is going to be, so the port connected to this guy is going to be our root port. And so that's our root port for switch D.